Can you solve all these buffer solutions questions? Which solution A and B of equal volume and concentration mix together to form a buffer? Option 1, nitric acid and potassium hydroxide. Option 2, propanoic acid and potassium hydroxide. Option 3, nitric acid and potassium nitrate. Option 4, propanoic acid and potassium propanoate. Keep it up, propanoic acid and potassium propanoate. What happens when H+ ions are added to a buffer solution? Option 1, the equilibrium position shifts to the left as H+ ions react with H3Cu ions. Option 2, the Phe increases due to the reaction with ethanoate ions. Option 3, the Phe decreases due to the reaction with ethanoic acid. Option 4, the equilibrium position shifts to the right as H+ ions react with H3Cu. You're on fire. The equilibrium position shifts to the right as H+ ions react with H3Cu. An example of a buffer solution is Option 1, 0.100 nosen and another and 0.100 nacl. Option 2, 0.100 nosen and return 0.100 nxco. Option 3, 0.100 nalder and 200 other and Henry Tim never know. Option 4, 0 and 100 and no 0.100 and f. Good job, 0 and 100 and 2 and 0.100 nano. Which combination will form a buffer solution? Option 1, 100.1 ASI with 50 milliliters of 0.1 of now. Option 2, 100 ml of 0.1 num and H3Cu with 50 ml of 0.1 now. And Option 3, 50 ml of 0.1 and C with 100 ml of 0.1 now. Option 4, 50 ml of 0 and 1 and H3Cu with 100 ml of 0.1 no. That's at 100 ml of 0.1 H3Cu with 50 ml of 0.1 now. Why do we use double arrow in ionization of sodium ethanoate? Option 1, because it's reversible reaction. Option 2, because it's irreversible reaction. Option 3, because it's acid. Option 4, because it's buffer solution. Nice, because it's reversible reaction. What happens when O ions are added to a buffer solution? Option 1, the Phe decreases due to the reaction with ethanoic acid. Option 2, the Phe increases due to the reaction with ethanoate ions. Option 3, the equilibrium position shifts to the left as O ions react with H3Cu ions. Option 4, the equilibrium position shifts to the right as O ions react with H3Cu. The Phe increases due to the reaction with ethanoate ions. Well done! Why do cells need a buffer system? Option 1, chemical processes in the cell are sensitive to the concentration of H+ and O. Option 2, cells do not have a buffer system. Option 3, cells need acids and bases to survive. Option 4, the fair range of cells can withstand large changes. Exactly, chemical processes in the cell are sensitive to the concentration of H+ and O. Acidic buffer is made up of Option 1, weak acid and weak base. Option 2, weak acid and its conjugate base. Option 3, weak acid and its conjugate salt. Option 4, strong acid and its conjugate base. Spot on, weak acid and its conjugate base. What is the Phe of a buffer that is 0.08 Embrdni and 0.1 Ha? The Chi of equal to 1.10 Option 1, 2.56. Option 2, 4 Auser. Option 3, 3.91. Option 4, 4 Windo. 3.1 is correct. Acidic buffer is made up of Option 1, weak acid and weak base. Option 2, weak acid and its conjugate salt. Option 3, weak acid and its conjugate base. Option 4, strong acid and its conjugate base. Nailed it, weak acid and its conjugate base. Which combination will form a buffer solution? Option 1, 100 ml of 0.1 ASI with 50 ml of a 0.1 now. Option 2, 100 ml of 0.1 H3Cu with 50 ml of 0.1 now. Option 3, 50 ml of 0.1 ASI with 100 ml of 0.1 now. Option 4, 50 ml of 0.1 H3Cu with 100 ml of 0.1 now. Perfect choice, 100 ml of 0.1 H3Cu with 50 ml of 0.1 now. Buffer is defined as Option 1, ability to resist a change. Option 2, ability to resist a Phe increase. Option 3, ability to prevent fetch from decreasing. Option 4, ability to resist of change when small amount of acid added. Yep, ability to resist change when small amount of acid added is correct. When making a buffer of fetch equal to 5, acids with the following K values are available, which would be the best acid to use. Option 1, 1.x10.5. Option 2, 4.9x10.10. Option 3, 1.x10a. Option 4, 3.0x10a. Great job, 0.x10.5. Which list of solutions is listed in order from containing the most solute to the least? Option 1, unsaturated, supersaturated, saturated. Option 2, saturated, unsaturated, supersaturated. Option 3, supersaturated, saturated, unsaturated. Option 4, unsaturated, saturated, supersaturated. You got it, unsaturated, saturated, supersaturated. This piece of Phe paper has been dipped into Option 1, an acid. Option 2, a base. Option 3, a neutral substance. Option 4, a buffer. Write a base. What does a buffer do? Option 1, it keeps the Phe of a solution from changing very much. Option 2, it maintains the amount of acid in a solution. Option 3, it maintains the amount of base in a solution. Option 4, it keeps the Phe of a solution from changing at all. On track, it keeps the flat of a solution from changing at all. What substances are present in a buffer? Option 1, a weak base or acid and its salt. Option 2, a hydrolyzing salt only. Option 3, a weak base or acid only. Option 4, a salt only. Well done, a weak base or acid and its salt. Which one is buffer solution of weak base and its conjugate? Option 1, ammonia with ammonium chloride. Option 2, ammonia with ammonium hydroxide. Option 3, ethanoic acid and sodium ethanoate. Option 4, ethanoic acid and ammonium hydroxide. Right choice, ammonia with ammonium chloride. Which combination will form a buffer solution? Option 1, 100.0 ml of 0.1 manhassi with 50.0 ml of 0.1 manao. Option 2, 50.0 ml of a 0.1 meswer hassi a height 100 eldomos do 1 mo. Option 3, 100.0 ml of 0.1 mextra 3 ku with 50.0 ml of 0.1 manao. Option 4, 50 ml of 0.1 men shrivku with 100 bottom ml of 0.1 no. Yes, 100 by of ml of 0.1 man che 3 ku with 50.0 ml is 0.1 mno is right. Which of the following is an example of a natural buffer? Option 1, blood. Option 2, fresh water. Option 3, acetic acid. Option 4, ammonium. Blood, great work. Buffer is defined as Option 1, ability to resist change. Option 2, ability to prevent fetch from decreasing. Option 3, ability to resist a fetch increase. Option 4, ability to resist Phe change when small amount of acid added. Yes, ability to resist fetch change when small amount of acid added is right. The addition of sulfurous acid and dash to water produces a buffer solution. Option 1, Na2SO4. Option 2, NaF. Option 3, spotless. Option 4, ASCLAL. You got it, spotless. Which of the following could be added to a solution of ethanoic acid to prepare a buffer? Option 1, NaO. Option 2, AXI. Option 3, NaCi. Option 4, more ethanoic acid. That's it, Niall. Why were the biological samples generally good buffers? Option 1, water is a poor buffer. Option 2, they need to maintain a Phe of 8.0 at all times. Option 3, all living organisms need to maintain homeostasis in terms of. Option 4, the samples came in liquid form. Spot on, all living organisms need to maintain homeostasis in terms of pH. What is the role of ACO3 ions in blood as a buffer? Option 1, to keep the blood Phe below 7. Option 2. To keep the blood pH between 7.35 and 7.45. Option 3. To increase the concentration of H plus ions in the blood. Option 4. To decrease the concentration of CO2 in the blood. Well done. To keep the blood Phe between 7.35 and 7.45. Buffer is defined as dash. Option 1. Ability to resist Phe change to make a stable solution. Option 2. Ability to prevent pH from decreasing. Option 3. Ability to resist a Phe increase. Option 4. Ability to resist a change when small amount of acid, base, or water added. On track, ability to resist Phe change when small amount of acid, base, or water added. Which of the following creates the most effective buffer? Option 1, 0.21 S and 0.6667 NAF. Option 2, 0.821 RESEF and 0.909 NAF. Option 3, 0.821 and 0.17 NAF. Option 4, 0.1 MEDI F and 0.217 NAF. Exactly 0.821 MAF and 109 NAF. Which solution A and B of equal volume and concentration mix together to form a buffer? Option 1, nitric acid and potassium hydroxide. Option 2, nitric acid and potassium nitrate. Option 3, propanoic acid and potassium hydroxide. Option 4, propanoic acid and potassium propanoate. Right choice, propanoic acid and potassium propanoate. What is a common buffer solution made of? Option 1, nitric acid and sodium nitrate. Option 2, ethanoic acid and sodium ethanoate. Option 3, hydrochloric acid and sodium chloride. Option 4, sulfuric acid and sodium sulfate. Keep it up, ethanoic acid and sodium ethanoate. Which of the following mixture that may produce buffer solution to work at pH of below 7? Option 1, NaO plus S7. Option 2, Co plus NaCH3Cu. Option 3, Co plus F. Option 4, HeCuO plus Ch3Cu. You're on fire, Co plus F. How you will get all these quiz questions in PDF books format. Option 1, contact Narayan Changder on Facebook. Option 2, send an email to cbs@gmail.com. Option 3, none of the above. Option 4, contact Narayan Changder. Contact Narayan Changder, great work.